Hello, and welcome to our webinar, Implementing AI from Starting Out to Scaling Up. I'm Abby Lundberg. I'm a business technology researcher and writer and president of Lundberg Media. I'll be moderating today's discussion. Today's topic is certainly timely. Organizations are moving quickly from asking if AI is right for them to exploring how to make the most of it for their customers, shareholders, and employees. In today's webinar, we'll cover real-world lessons learned in implementing AI, from how to get started to what it takes to scale up to an enterprise approach. We've got a terrific slate of speakers, starting with Jillian Armstrong, Technical Lead for Cognitive Technologies at Liberty Mutual Insurance. Jillian would be followed by John Ashley, Head of the Strategy Team for the Global Financial Services Industry at NVIDIA. Eric Kessler, Data Scientist and Practice Manager for AI and Machine Learning at AWS Professional Services, will wrap things up. They'll talk about how to identify the right opportunities for your business, why your most critical AI resources are data and talent, and what to do to cultivate them, and what to consider as you scale up from experiments to a full-on AI roadmap for your business. We're really fortunate to have Jillian Armstrong with us today. Jillian leads a team at Liberty Mutual Insurance that is working with cognitive technologies to improve productivity and augment human intelligence within the enterprise. They're using machine learning and building out conversational platforms using natural language understanding and processing. Much of Jillian's work centers around the new paradigms that cognitive technologies bring to human-computer interactions. Today, she'll talk about the approach Liberty Mutual took to getting started with AI and the lessons they've learned along the way. Jillian, it's great to have you here. Take it away.
Thanks very much, Abby. So I'm Jillian Armstrong, and I'm a technologist working for Liberty Mutual Insurance. And I've been working in the space of applied AI for the last few years, which means I've been both exploring and applying AI to solve real business problems within Liberty. And I'm going to give a really high-level overview of what I've been learning, and hopefully we'll have some really great discussion after the talks. Wonderful. So for most of us, myself included, artificial intelligence can seem pretty intimidating when you first start out. But the good news is there is absolutely ways to get started and to start benefiting from AI within your company without having to send everybody out to get a PhD. And not only is it possible to get started right away, it is actually critical that you do get started right away. And the reason for that is that bringing AI into any large existing company is just going to take time. The field of AI is moving very, very quickly, but moving quickly is something that is very difficult for most large enterprises to do. Liberty Mutual, it's a large 100-year-old company, and although we have lots of really innovative and fast-moving work, we also have plenty of large, stable legacy systems. And learning and scaling just takes time, and there aren't that many shortcuts. So what do you do? Well, the first thing you need to do is to get to grips with where you're at. So you're going to need to start out with education and awareness. And that's really important for everyone. You don't need to be an expert to get started, but you do need to understand what AI can and cannot do. And you need to understand the opportunities and risks. You're going to need to assess your current systems. So you may well be like us and have plenty of legacy systems. And just because something's legacy doesn't mean that it isn't doing a great job right now or that it was built poorly. It just means that at the time it was built, it wasn't designed for some of the new capabilities that are now available. And some of your systems, you might be able to modernize them. Some of them are just going to need replaced. And for almost everyone, AI is going to require the use of the cloud. And some of you out there might already be running everything in the cloud, and some of you might be running nothing in the cloud. Here in Liberty Mutual, we are actively looking to skill up all of our in-house developers, and we're moving things out into the cloud, and we're building everything new out in the cloud from the start. Data, absolutely critical. I'm going to talk more about that, and so will everyone else. And although you can start without expert knowledge, you are going to have to start to expand your skill sets, either by training your own people or starting to hire in some new people. And all of this is going to be based on understanding where you are and where you want to get to. And this is why a strategy is so important. Now, sometimes people say strategy, and they mean some sort of abstract vision. That is not at all what I'm talking about. This has to be an action plan, right? Finding the right places, getting it right, rolling it out, all without impacting your current business. That requires thoughtfulness, and it requires time. It is slow and steady work. But AI is going to be vital for the future of every business, which is why every business needs to be looking at this now. So you're all in. You want to get started right away. So your first question is probably, should you build something or should you go out and buy something? And the answer is that you should do both, absolutely. Your first choice as you get started will likely be prepackaged solutions or services. Being able to use a complete product lets you start really quickly. It lets you start with partnering with a company that's probably further along in AI thinking. But another great option is using AI services. All the major cloud providers have offerings. Most of them are pay per use. So if it doesn't work for you, you're not tied in. You can just switch to something else. And we find that using cloud services to extend or add intelligence into existing systems has been a really powerful way to get started. And once you've really started to understand the value that AI can bring and where it's going to work for you and where it's not going to work for you, then you can look for spaces to differentiate. And it's only then that you want to invest in totally custom solutions. Now, notice that everything else is still there on the screen. I would expect that everyone is going to have a mix of these things. And don't build what you can buy. And don't buy what should be making you different to your competitors. So how are you going to get your learnings? How are you going to find your differentiators? Well, good question. Finding the right places to start is definitely difficult. And we find that internal systems are a really great place to start, especially if they're not business impacting. We've been building out an internal digital assistant for a few years now. And we've been able to try out lots of interesting things there. For instance, adding a chatbot. And using internal systems lets you try really innovative things without the same risk. And once you've learned and are confident, then you can start to apply that within your customer-facing systems. So, for example, taking some of that chatbot technology from our employee assistant and using it to apply for building a virtual agent in the call center. We're also taking the chance to try out more experimental things, so maybe image recognition, transcription, machine comprehension, and other technologies. And for the more experimental stuff, what you want to do as you roll them out into your customer applications is to use it to augment rather than to replace what you have, at least initially. And that lets you assess the quality much more easily and roll back if you need. And as your skills and confidence grow, there should be less need to work in only safe to fail spaces. Now, data, everyone's favorite subject. I really can't emphasize enough how important the right data is. And this is where existing companies have an advantage over new startups. New companies can't understand their customer in the way that an existing company can or should. They just don't have the data over time. They don't have the same amount of customer base. But you absolutely shouldn't be complacent, because it's not unusual for that data to be spread across dozens or maybe more than that of different systems in different formats. So like I mentioned at the start, you need to understand where you are. And that means not only what data you have, but where it is and who can access it. Opening up access to your data to other people so it can be shared can be really powerful, but that needs to be balanced with protecting your customers' privacy, which is much more important than being able to recommend someone the right shoes. And even if you have a lot of data, it may not be the right data. So for instance, for our employee assistant chatbot, we were able to take data from things like what people had searched for or what sort of queries they made to internal groups. But while that told us what sort of things people might ask, it didn't tell us how they were going to ask them when they were talking to a chatbot. So we needed to gather that data organically. Conversely, the teams that were building out the virtual agents for the call center had a lot of historical call data. But machine learning systems need text. And although we had the right data or close to it, it wasn't immediately in the right format. And so it needed pre-processed before it could be used to train the chatbots. Now, pre-processing is one thing, but another bigger problem you might have is the data quality. So potentially, in some of your data, when it was collected, there was very little validation done, or maybe it's simply outdated now. You may also be missing large chunks of what you need, so maybe whole groups of customers aren't represented in some areas of your data. There can be rules. So for instance, in Europe, you can't use a customer's data for anything apart from what you told them you were collecting it for. And even if you're following all the legal requirements, there may still be ethical questions. If you wouldn't feel comfortable with what you're doing appearing on the front of a newspaper, you really do need to consider if it is something that you should be doing. If you do have a lot of data in your company, it really is a goldmine, even if it might be hard work to use it. But don't squander that goldmine. AI advances mean that newcomers are going to be able to do more with less. They will catch up quickly. So really do start now. And although I said you don't need to be an expert to start out, there are new skills you're going to have to start to put in place. And when you think about new skills, you're probably immediately thinking about things like data science or machine learning engineering. However, regular software engineers are going to have to develop a whole new set of skills too around how to apply and test machine learning systems. Business requirements for AI systems are going to be different. You have to change how you think about and frame those problems. And there are changes to the user experience. So think about things like voice technologies. For those, you need an understanding of linguistics, script writing, speech psychology. And if you're moving to a gesture-based system like AR or VR, all of a sudden you need to understand something about biology. And we've already mentioned data. When you're using a lot of data, it's critical that it's used properly, that you understand the legal requirements, the compliance requirements, that it's kept secure, that your users are protected. And many of the things you need to think about will be the same as what you already know. But understanding where it is the same and where machine learning means that it's different is really important. And what about your marketing team? Do they know what you're building? Do they understand it? Do they know how to describe it? And what about PR? If, and hopefully never, there ever was a problem, would they know how to respond? Would they know what to say if they're asked about possible bias or potential job losses? AI does bring risks, but it also brings so many opportunities. But unfortunately, even though I said you needed to think about where you wanted to get to, the honest truth is that you are never done. You are continuously going to have to work to improve. Systems that use AI are learning systems. You're going to need to keep making them smarter. And the technology is moving so quickly that things that are not possible now will be in no time at all. So you need to be setting yourself up to take advantage of those things as they come along. I am really, really excited about the possibilities that AI is opening up. But one thing is very clear. There is a lot of work ahead for everyone. Thank you very much.
Jillian, thank you so much. It's so great to hear from a practitioner, someone who's actually living this, and to kind of walk through some of those practical aspects. I really appreciate your presentation. Our next speaker is John Ashley. John is Director of Global Financial Services Strategy at NVIDIA. John started NVIDIA's professional services deep learning practice. And over the years, he's helped many customers and partners adopt and deliver deep learning solutions. John holds a doctoral degree in computational sciences and informatics, and he has a US patent in predictive analytics. His practical experience is quite broad. It includes working as a data scientist, project manager, systems architect, DBA, and developer. Today, John will talk about how to frame your AI aspirations, assessing the data that you'll need, and how to get started now without putting your enterprise at risk. John, thank you so much for being here.
Thank you, Abby. So this is a cut down version of a longer presentation that we've delivered myself and my team at NVIDIA in the professional services space to a number of companies. And I think you'll find it echoes what you heard from Jillian pretty closely. I think they're, I would say a very good example of a company that's really taken a thoughtful approach to how they're going to adopt AI. And that's what we would encourage you to do as well. And we've encouraged partners to do. Really look at their aspirations. Where do they want to get? What kind of company do they want to be as they transform themselves, either adding AI in here and there, or really becoming an AI-driven firm? We'll talk a little bit about some of the things you should think about your data. It can be a gold mine, and there also may be other data you can get to easily that increases the value of your data. Data is subject to network effects, and that's important to think about and remember. And finally, some cautions for the journey, right? Building your AI practice, as Jillian pointed out, you're never done. The projects are never really done. The systems are never done. It is a journey, and you will get better at it as you do more of it. So those are the kind of things I'm going to talk about very briefly here today. The first thing is, how important is AI to the future of your company? Do you want to be a leader or a disruptor in your industry and use AI to do it? And there's some questions you want to ask, because ultimately the first thing your executives will say is, yes, we want to be a leader. We want to disrupt things. And the first question is, can you win? Realistically, look at your company, look at your industry, and decides whose pockets you're fighting. AI, it turns out, can be a very expensive game if you want to play at the very front end, right? That front end requires talent, it requires compute, it requires data, and it is going to generate a lot of failures. And in some companies, that will be fine. But in other companies, being associated with a string of failed projects is not good for your career. The other thing that is realistically common for every leader disruptor company I know of in the AI that's using AI to change their business is their best data scientists spend a lot of time playing. There's a whole lot of new technology. This area is advancing very quickly. It is much more art than science. And as a result, adapting those new research things to the ideas you have, to the projects you might be able to do, means that you are going to have very expensive data scientists cataloging their music library and trying to reproduce rock albums or trying to categorize these things, because that's how they can play with this new research technique that came out of this new paper that hasn't even been presented at a conference yet. So you really, if you want to be in that leadership category, in that disruptor category, you need to think about, is that a place you can actually stand to be culturally, financially, and just from a business perspective. You may decide you want to be a fast follower, and that is a much more achievable place, right? You don't need as much A-level talent. You still want some if you can get it. But even what I would call, strong B talent is going to be able to keep you up with the proviso that you are going to have to give them time to stay sharp, right? They are going to still be duplicating leading papers in the field, at least the ones that are obviously applicable to stuff that you're doing. And that means there's going to be some play time involved. They are not going to be 100% working on projects that are moving the ball forward in an obvious way. The other thing you need to do if you want to adopt this plan is you have to have a flexible budgeting program in place, right? Because you're going to find a paper is going to get published or a competitor is going to launch a product, and you're going to realize that you could do that, but it's going to take time, it's going to take effort, and you didn't budget for it, so now you have to wait another year to get started. And that's going to make you a very slow follower. So I think there's a way to be a fast follower here, but it is not for every company either. You really need to be very realistic about whether that's a space you want to be. For a lot of companies, their AI approach may be, I'm going to buy it later. Unless it's absolutely core to my business, I'm going to count on some startup or some big software vendor to build out the feature I need. I don't need to be first, right? In my market, being first does not, it's not a winner take all kind of thing. I'm going to put together a skeleton crew, and they're going to do a lot of reading, a lot of research, go to a lot of conferences, talk to a lot of companies. But we're not going to try and build the world's best chatbot, or we're not going to try and build a neural translation system that will, let us translate all our documents into Spanish for our South American subsidiaries. So, again, this is a very achievable place, but it may not be a very smart place to be, and that's for you to decide in the context of your business. And then in each of these areas, right, in every area of your business, and whether you're trying to be a leader or a fast follower, or you're mostly going to buy it later, you definitely need to figure out how much of that you want to have as native capability. Sometimes maybe you want to be a leader disruptor, but today you can't get there on your own, right? You just know you can't. Maybe you can find a partner that can, right? There are boutique firms that do nothing but deep learning, AI, data science. There are large consultancies that have practices in this area. If you have the ability to buy that team that way, that is definitely a way to get to someone in your in-house with the expertise you need to help you build out in a focus area or two. And finally, of course, you can always buy solutions, or you can partner for semi-custom solutions, especially in the startup ecosystem today. In AI-powered stuff, for anything you want to do, there is a startup out there that is trying to build that as a product. And so if you want it first or you want it early, you can get them in-house. They will do, effectively, they will become your development arm, they're going to take the product, some of the IP away with them, but you'll have gotten access to it first, and you, of course, will have gotten access to all that expertise along the way while you start up your own practice. So it's actually a pretty valid strategy for some things, and worth thinking about. In terms of data, the real big difference in data and the thing that marks out deep learning from machine learning techniques, more traditional ones, is that deep learning has a much easier time dealing with unstructured data. And by that, I mean video, I mean images, I mean audio, and I mean text. And this data tends to be the data that as a firm, we have done the least good job managing. We have the least knowledge of the quality of that data. We have the least metadata collected about it. And so from a data inventory perspective, a lot of times we don't know what we really have. And that's important, right? We know a lot about our structured data. And so one of the interesting questions is to think about is, what is your unstructured data? Do you have a good inventory of it? And is there any metadata, any structured data you can infer from your unstructured data that you just haven't done or you haven't exposed easily? So maybe there's information you have about how you collected the data, or the cameras that you were using at the time, or other things that you could add in with your unstructured data to make a more rich source, and also to help you link that with other things later. And that really, right, linkages and labels are key to this data. If you're looking at unstructured data, especially text, logs, in a lot of cases for customer support, you have audio recordings of all the calls, but you don't have text. And so first step one is to do some kind of a speech to text process on that, and then have someone go in and manually check things and clean up the bits that the speech to text recognition didn't get correct. You need to look at linking your unstructured data together and linking it with your structured data. And a thing that you will discover is that timestamps for most companies are not terribly reliable, and you're going to be depending on those to link things together. So always, right, just a standard data science issue there with timestamps. And then the other thing you need to think about is, right, just because you don't have the data labeled the way you need it or collected the way you need it today, doesn't mean you couldn't have it that way tomorrow. It may be that you have an area that if you only had this data, if only you'd been labeling it this way, you could do this project. Well, maybe you can start doing that collection that way now, so that a year from now you have enough data to do the AI-powered project that you've been wanting to do ever since you discovered that you could do these things with AI. So definitely, it's not just about what you have, it's about what changes you could make to your current processes to make the data you have more usable as you go forward. And another issue, and I think we touched on this, right? Jillian touched on this already. I think you'll hear more about this, is some of your data is private. It's really private. It's core to your company. It's customer PII data. But some of it isn't. Some of it is stuff you have to file regulatory filings, or it's not that private. Things like certain kinds of fraud data. Your set of that data, your exposure to fraudsters may not be big enough to make it easy for you to build the fraud detector you'd like. But as an industry, it may be that you could share fraud data, right, on either scammers or maybe particular doctors or shops that are involved in fraud. You might be able to arrange to share those cases with your industry cohorts, and suddenly you all have a lot more data. And in general, if it's for something like fraud, your regulator is unlikely to view that as collusion. So you need to think creatively about how you can enrich your data. It's not just what data you have now, it's obviously also what data you could get. And there's other ways to get it than just buying it, right? Obviously, you can just buy data from some providers. The quality is questionable sometimes. But you can also sponsor research. You could find an affiliate yourself with a university that might either have access to more data than you have, or be able to get access to data through either a government research program or some other industry group, where people are willing to share things with a university that maybe they won't share with a competitor. So this is a creative way sometimes to acquire data to fill a gap in what you have internally. And finally, I want to talk about the journey. AI is a treadmill, right? Once you get on, you really can't get off. And it generally is just going to be going faster and faster. But we always advise, right, really take a measured approach, crawl, walk, run. Then decide if you're going to branch out. One of the things we don't see planned in most project plans when you start is testing your technical and human processes. And this goes back again to something Jillian said. It's not just your data scientists that are involved, right? Your data scientists can build the best model ever. And if they've built it in a hodgepodge of tools, then a delicate scaffolding of dependencies and libraries and open source projects, and your production team looks at that and says, we can't put this anywhere near our production systems, then you have a real issue there. And so you need to be thinking about that across the project when you start. How are you going to take this project over the finish line? And make sure that you've got the handoffs and these technical things all set up. Another thing that I think is key is, right, expect to fail. If your project does not have enough experiments that are failing, you're doing it wrong. Unless you're talking about computer vision, which is the most well understood area of modern AI, I would say. If the projects aren't failing, you've waited too long, you've gathered too much data, you've done something wrong. The last point I think I'd make there is there's a temptation to decide on a set of standards and build out a big infrastructure all at once. And the bottlenecks are never going to be where you expect them to be in the architecture. The behavioral, the industry is moving so fast, the tools are moving so fast, that it makes sense to take almost more of a startup approach, right? Plan, practice, but don't commit large chunks until you have to, right? Make those decisions, bind them as late as possible. And finally, understand your risk appetite. Keep your expectations and risks low until you've at least done one end-to-end project. Whether that project is internally facing, I know of companies, NVIDIA is one, we have a facial recognition system in our new headquarters building that will open the security gates for me when I walk up to it because it recognizes my face. But again, the risk on that's low. I'm already in the building. It's not opening the door for everybody. I'm an employee. I'm willing to accept the fact that sometimes the gate doesn't open for me and I have to use my badge. And again, you heard that from Jillian, right? Those internal facing projects can be a great place to start. Even a security project, right? Looking at the cars coming into your parking lot and checking, reading the license plates, making sure they're the cars you expect in your parking lot. I would say outside of image classification, deep learning is an evolving art. Chatbots are a really popular place to start because the risk is low. They're actually one of the more complicated things to build. So if you're going to build that, again, plan on a lot of experiments, plan on a lot of iterations, before you get it right. And if you can face one internally before it goes external, or you can put it in a very low risk place externally, that's a good plan. And the more advanced techniques, the really cool stuff, right? The stuff that DeepMind and Google Brain are publishing, GANs, reinforcement learning. These are the hardest problems. They're going to take the most talent, the most time, and have the most risk. So just kind of be aware of that fact as you're doing your planning. And that brings me to the end of sort of my remarks.
Well, John, thank you so much. What a great way of framing how people should actually start thinking about getting into this. So thank you so much for that. Our final speaker is Eric Kessler. Eric is a data scientist and practice manager for AI and machine learning at AWS Professional Services. As part of the Amazon Machine Learning Solutions Lab, Eric and his team help customers design, develop, and deploy scalable machine learning solutions on AWS to transform their businesses. He has years of experience building enterprise-scale ML systems in areas such as natural language processing, fraud detection, and pricing optimization. Eric has a PhD in physics from the Max Planck Institute for Quantum Optics and has worked several years as an academic researcher in quantum information theory at Harvard University, so practical and theoretical too. Today, Eric will talk about the key organizational structures you'll need to support machine learning in your enterprise. Eric, thank you so much for joining us.
Thank you very much, Abby, and it's a real pleasure to be able to speak here today. And as Abby said, my team, I'm heading up the consulting division for machine learning in the Northeast for AWS. And so my team works directly together with customers building machine learning solutions. And for that delay, one of the questions that our customers very often ask us is, how can we build a competitive advantage in machine learning? And when you look at the broadly speaking, the three different components that you need to build a successful machine learning system, you need algorithms, you need the data that the algorithms operate on, and you need the talent, the understanding what a particular solution can do for your business, how to implement a solution, and finally, how to bring it to production. Now, it may be easy to think that one of the key differentiator in that space would be the algorithms, but that is in fact not true at all. As a matter of fact, the machine learning community is an exceptionally open space, and most of the most advanced machine learning algorithms are in fact open sourced and published in academic journals. It is very true that data is one of the key differentiators, but as Jillian and John have done such a great job emphasizing that point, I am not going to talk about this. Instead, I do want to focus on how do you structure your teams and your organizational structure around your talent in order to build an organization that is successfully bringing machine learning systems to production and bringing them in a position to deliver business value. So the question is, how does the optimal organization look like? And when you look at the typical, when you look at the when you look at the challenges of machine learning and the nature of machine learning, these different aspects pose severe organizational challenges, right? We discussed a little bit of that previously in the previous two talks. Machine learning is inherently iterative and experimental, right? An algorithm is never considered to be done. There's a continuous adjustment to the underlying data, to the changing business requirements. And as John pointed out, it is very experimental, and not only during the development stage, might I add, but also all the way down to deploying your machine learning system into production, because it is not at all guaranteed that your machine learning model will have the same performance that you saw offline when you were developing it, when you bring it actually in front of your customers. There are many factors that I'm going to talk about a little bit further down below. but the experimentation stage stretches across the whole pipeline. You have dynamic business specifications in the sense that when you think about the traditional IT system, it is very natural to find what is the system supposed to do when I take a certain action, right? If I click on this button on my web page, I want this thing to happen. Well, in machine learning, these specifications are much more fluent and more dynamic, right? You want to recommend the optimal movie to your viewer, or show another product that he's likely to buy. So the definitions of what that means are often not very clear and need to be worked out very carefully. When we come to things like testing your machine learning model, this is not at all a trivial task, right? Because of these dynamic business specifications, it is really difficult to decide what is the expected reaction from my machine learning system and how do I make sure that what I have deployed is delivering the right results. You have things like feedback loops. Once the system is in production, because you're showing them certain videos, certain movies to watch, they will be more likely to click on them. And that will impact your future model retraining, the data distribution that you use for your machine learning models. And then also when you think about the deployment patterns, they are very different from traditional IT systems. Typically, you would release a new system, if you have developed a new feature or a bug fix. But in machine learning, the deployment is an integral part of the process because the model needs to be continuously retrained and continuously redeployed to stay up to date with the underlying data distribution. So now when you consider these challenges and you look at organizational structures for IT organizations that we are very familiar with, where you have say a business unit and the data scientist operates within that business unit, builds machine learning models, translates the business problem to machine learning, and works with the data. And then on the other side, you have a fairly strict division with an enterprise IT organization that captures the requirements, develops the pipeline, and deploys the model, and then tries to operate and maintain the model going forward and manage potential change requests. You see there will be inherent conflicts with this organizational structure and the challenges that I've laid out before. The iterative process, for example, means that there must be a continuous interchange between the data scientist and the development arm. The dynamic specifications are in direct conflict with the model of development by specification. Testing is a real challenge. I already spoke about that. The feedback loop means that the machine learning knowledge and the model development extends far into the deployment side of things, and the deployment patterns make it really difficult for IT organization to manage these. And also when you think about the management of change requests, these are often inherently related to the design of the model. So when you look at what in my experience and the experience of my team is an ideal organization or an ideal quote unquote machine learning team, what that looks like, we think about it as a very small team of vertically integrated skill sets. On the one hand, we want to have data scientists, machine learning engineers, and product managers or some representation from the project and business side working very closely together. The data scientists in building the model need to understand the downstream applications, what it means when we want to deploy this model, and vice versa. The ML engineers that are responsible for building the pipeline and the deployment need to understand what the model does and how it does it, and watch out for certain feedback effects in the deployment pattern. And all of them need to understand the business requirements and how machine learning influences those. And then this core team can be extended on a flexible basis by different specialty skills on the front-end development, by business subject matter experts, or other cloud subject matter experts in the areas of security, networking, DevOps or big data, whatever might be needed on that side. So in this space now is the question, how can you find a path from the traditional operational model to a small integrated team and an organizational structures that can help bridge the development of these teams, especially in the early stages. And what we see many times is that business units within the enterprise face a chicken and egg problem. On the one hand, when they start out, they don't have typically the machine learning talent to identify and develop and recognize machine learning opportunities that could have a significant business impact. And then on the flip side, without a full pipeline and a clear path for developing more and more machine learning solutions, it's really hard for these business units to attract and retain this talent. One successful strategy that we have seen is accelerating or catalyzing this process through what we call, quote unquote, a machine learning center of excellence, which can at the beginning achieve this scaling threshold by working together with multiple business units within the enterprise and provide a full stack machine learning development service to different business units across all functions, from the machine learning development, from the deployment down to the full product development. And again, when supporting the business units, it's critical that we have these small teams that can act in a very agile fashion and address the entire problem coherently end to end. The COE can also help identify and develop machine learning roadmaps for the individual business units, and most importantly, to a degree, because the data science talent out there is very scarce, and it's really hard to keep them happy and give them interesting projects to do. By having this centralized unit at the beginning, it's a really good way to fight attrition and help them shape their own pipeline, in a sense, to identify the most interesting and rewarding machine learning projects across the enterprise. But of course, it doesn't stop there. Ultimately, the goal is that through the COE as a catalyst, we want to enable the entire organization. And here it is really critical to set up the incentive structure correctly to disincent what I would call, quote unquote, empire building, right? The goal here is not to build a massive centralized machine learning organization that acts as a gatekeeper. Quite the opposite. The COE should be rewarded to support the decentralization through the difficult initial stages in the machine learning journey. Right? They should support in hiring and should support in building machine learning strategies for the different units, help build that expertise, and provide best practice guidance and support throughout the process. And finally, just to end on that note, what these best practices look like when you think about machine learning in production, because it is a very different thing from just building a simple model to running an end-to-end machine learning application that is interacting with your customers. So we always like to think of these tenets that we work with our customers to go towards. On the one hand, designing everything for scalability, elasticity, for costing and stability. And then one important point is to treat your data with the same rigor that you're already used to treat your code. That means extending source control to different stages of your data pipeline, and being very diligent about data processes in your company, enable full transparency and auditability by building full logging functionalities across your machine learning pipeline, automate as much as possible. So these are all things that come directly from best practices in software development, but come with additional challenges in machine learning. And the consistency by design is something very important, which means that you have to have automatic controls that make sure that what you see during the training stage will persist in production.
Eric, thank you so much.
Thank you very much.
That was fantastic. And we've already gotten some tremendous questions coming in from the audience during the presentation. And I think you guys did such a great job because John and Eric, you actually answered some of the questions that were asked from earlier presentations. So really, you covered the stuff that our audience wanted to know about. For the audience, we will continue to take your questions for the remainder of the hour. You can submit those by entering them into the question module. So to start off, Jillian, this one was for you. What is the criteria that you are using to identify experimental AI initiatives? And how and at what point are you integrating the experimental initiatives into actual business?
So we have some emerging technology spaces and an incubator space. And they spend a lot of time talking to the business, finding business problems where we think we could start to apply AI, or maybe sometimes they find just they can help them with their processes in other ways without anything too fancy. And what they do is they go ahead and start to run some early POCs. They try to find out if it is something that is going to work. And where they find that, then they go ahead and work with teams to try and get it rolled out. Sometimes the technology just isn't there yet, or sometimes it just isn't going to work. We also do hackathons. So last week, we actually just did hackathons. Some of the teams that won were actually using machine learning. So we in that case, we let all the developers in the company just go out and explore and try and find business problems they thought could be solved in different ways and go and build something. So we've seen some really interesting things coming out of that just by sort of crowdsourcing those ideas.
Very cool. As a sort of a related question and a follow-up, and this is for anyone who wants to answer, at what point do you start, at what point do people start trusting the insights that are coming from the AI? And again, sort of like, where do you draw the line to, okay, we trust this enough to go forward?
So I guess what I've seen is it really is it's very subjective. And in large part, it depends on how much you've prepared management and executives to accept those results. So if you just have a project and it has some results, for the most part, they're going to be very skeptical. I think you have a parallel track for those first couple projects where you have to be educating your executives on why, how you train these things, how you build these AI models, how you believe if they're working, and really help them feel comfortable asking those questions and understanding the answers. It's a fairly involved, it's a high touch effort, but once you do it once, it pays off, and you have smart executive sponsors then.
Great.
Anyone else?
Well, actually, I want to go on to the next question because we've got so many great questions. I think this is one that's probably for Eric, you and John both maybe. What percentage of customers are using machine learning in production versus proof of concept at this point? And are there any sort of top industries that are leading the way?
Yeah, absolutely. I'm happy to take this question. So our team is really focused on this question. And I agree with the premise of the question that I've seen it in my past careers also, that it is a very frequent thing that happens, that because of the experimental nature, things don't work out and end up on the shelf. But we are really focused when working with customers that we have a clear path to production. In terms of giving exact numbers, it's really hard to tell. But I think the important thing is, even if the first experiment fails, is to continue on that path and work towards a solution that delivers the right results and can be brought into production in the long term.
You all talked about talent, and sort of how you think about what you need on your teams, and it's obviously related to where you're positioning yourself in terms of that, are we a leader, fast follower, et cetera. So the question from the audience is, when you're looking outside for talent to help in implementing AI, what are the skills and graduate level degrees that you look for? And are there things that you wish you could get from university graduate programs, for example, that you're not seeing today? So what do you really need, and where are the gaps?
So I guess when I'm hiring, I'll just jump in. Right, I'm looking for diversity of background because when I was leading a consulting practice, and now even on the finance side, the industry has a lot of segments, right? So from a consulting perspective, the more different backgrounds, the more varied the backgrounds I have on the team, the more projects I'm likely to have them be able to bring an insight to. It may be different, you may get a different answer from Jillian or Eric.
I would just say it depends what you're trying to do. So if you need to look at where the gaps are, and you need to look at what sort of projects you want to do. So we are doing a number of different things. We are certainly bringing in more people who have machine learning in their backgrounds, who have studied that. But we also are doing a lot of upskilling of our own staff, because it is really important that everybody understands.
Yeah,
So
I would maybe add one sentence to this.
Go ahead.
Sorry, Ed. Yeah, the ideal machine learning candidate, has a university academic degree in mathematical modeling, knows how to build production systems, and has business acumen, right? But these people are really hard to come by, and I think tying that back to my presentation, that is one of the crucial points why you want to work with a diverse team that is closely tied together, right? Because these people are interested in learning from the other fields, and so rather than hiring the unicorn, you should rather breed it, having it in a smart team.
And one of the things I think is really interesting right now is it seems like it's almost a moving target. As more solutions come onto the market, maybe a couple of years ago, if you wanted to do AI, you had to have pretty sophisticated people on your team to do that because you were building the models and the algorithms yourself. But it seems like now more and more every day that there are things available in the marketplace that you don't need to have necessarily those PhD level skills. So I guess my question is, if that's the case, and I'm a retailer and I want to get into AI, what's sort of the base skills that you need? Because even if you're going to buy everything, you still need people inside that understand what it's all about, right?
So I guess I'll jump in again because I've actually had that customer. I think the thing you're looking for is you need someone with a vision across that has a broad vision. So to Eric's point, they have to have some business acumen and they have to have some technical skills. If you're the retailer and you're going to buy it all, they don't necessarily have to be able to build everything, but they have to understand how to work with data, right? I'd be looking for someone that had some kind of a data science background in practice, not in theory, right? So that they understand what dirty data is and they understand what kinds of things to look for. In terms of implementation, you're absolutely right. You can get people who can write TensorFlow or PyTorch code now. That's easy to find people with that on their resume. It's hard to find people that can actually, again, to Eric's point and a little bit to Jillian's point, fill in the gaps in your team and take something from science project to production system. That's still hard to find.
So we had a number of questions relating to data. And one of them was specifically around, if you have to anonymize customer data and you're anonymizing customer data, does that make it more difficult to build your models? And if so, how do you work around that?
I think it depends on your business problem. It does. I mean, as a developer, I'm sure as data scientists, you just love to have all the data in the world and just use it for everything. But it is so important that people's data is protected and we're not just ending up all as a collection of data points. That would not be a good thing. So it will limit what you can do, but I think it's also a really good thing because it really forces you to think about what you're actually building and what that machine is actually going to do with the data. I think ethics is a big thing we've been talking a lot about. And so whenever you sit down and really think about, well, is this actually good for our customers and what are we actually doing here? And do we really need to put this data in? I think it's a really good thing and a really good idea that everybody should be thinking about it up front.
We have time for one more question. And Eric, I'm going to pitch this one to you. We had a number of questions come to you just teed us up perfectly, Jillian, there with referring to the bias question. So there are a couple of questions around how do we prevent human cognitive bias from being built into algorithms by their creators. Related to that, what are your views about AI ethics boards? And is there a relationship? Well, I'm going to just stop there and ask that question because I think this is a big topic. We could do a whole hour on that.
Yeah, no, absolutely. It's a big topic, and to Jillian's point previously, a really important one. I think what we see in practice often is that that certain bias and ethics checks are being formalized and standardized, and being made part of a deployment pipeline, a CI/CD pipeline, where you have certain tests for biases in your predictions that you can evaluate and have a check before you actually put a model into production. But then also this ties obviously into the live production monitoring, right? You should never fully trust them. Always be skeptical about what you put in production. Keep logging everything and have automated checks if you see some unusual patterns occur, and that can be both on the bias, ethical bias, or other biases sign, or just from the model accuracy. I think we could talk a lot more about that. There are methods from a data science side how to debias data sets, remove certain gender biases from for example, natural language processing tasks. But that gets then really deep into it. But yeah, I think it's a really important question.
Yeah, and I mean, I think there's this combination of who's on the team. Is a diverse team? Are people trained against to recognize and avoid cognitive bias in all the things that you talked about, Eric? So unfortunately, we are out of time. So thank you, Jillian, John, and Eric for this really interesting and informative talk. And thank you in the audience for your attention and great questions. I'm sorry we didn't have time for more of them. Over the next few days, please look out for a feedback survey we'll send via email. We really appreciate your thoughts and opinions. And as I said at the top, an audio recording of this program will be available within 3 to 4 business days, and we'll let you know how to access that. A final thank you to our sponsors, Amazon Web Services and NVIDIA.